The BulkyMIDI-32 is my version of the hardware for putting together a MT-32 Pi solution, a way of emulating vintage MIDI modules. Join me for another basement adventure as I tackle the task of soldering one together. And we're back. Well, mostly, as most of this video has been recorded while a little stuffy, to say the least. For what the BulkyMIDI-32 is and the idea behind it, I've covered that in a separate introduction video, though a demonstration might be all that you need. In this case, the start of Monkey Island 2. Directly following that, a word about today's sponsor, PCBWay. This video has been sponsored by PCBWay, a full-feature custom PCB prototyping service. It's a service that I've come to use fairly regularly for 5 years as a hobbyist. Getting an instant quote is usually easy. You enter the physical dimensions of the PCB, how many you want, and then finally pick the color you want the PCB to have, calculate the price, save to the cart and upload a zipped copy of your Gerber files. Pay for your order and your PCB can be ready for assembly after just a few days. And with the magic of jump cuts, my PCBs have already been delivered to my front door. For the build I'm doing today, you're going to need 4 separate PCBs. While you could get away with only the main PCB, but that's besides the point of the project. The first one is the faceplate FB2. It's purely a cosmetic part. The main PCB is where we'll be mounting most of our components. Do however note that as it can be used standalone without the other 3 PCBs, it has provisions for mounting switches and an OLED display that we won't be installing here today. Instead, we'll be substituting the control scheme for a rotor encoder, be installed on a front-facing panel such as this one. A second cosmetic PCB, the faceplate FP2, will also be used. The design of it implies that we'll be using an 1.3-inch OLED display and without an extras panel. While it may not be immediately clear how these PCBs are supposed to fit together, but without the faceplates in place you should see the framework plain enough. The details we'll handle as we get to them. Back at the workbench, I'm just going to give the PCB a little bit of cleaning with some IPA. If you've never seen a man clean before, then that was it. Just need to buy the right kind of cleaner. From this point on in the video, I'll be focusing more on the task of putting the whole thing together. Keep watching and listen to the tune while I do so, or skip ahead if there's a specific step you need help with. Resistors are pretty straightforward. You just install the values printed on the board, starting in the upper right corner, as I always seem to forget about that one. Truly riveting stuff. We do, however, need to talk about R7. It's used for the power LED on the front, which means that you're supposed to look at a datasheet, calculate with a 3.3 input voltage, and then calculate a suitable resistor value for your LED, or just pick something high enough so that you don't go blind. Finally, just solder them in place. starting with R7 so that you know that the time for maths have already passed. There's only one diode, in this case a 1N4148 small signal diode. It's the small glass thing usually included in electronic parts kits. One side of it has a black band and we need to match it to the footprint on your PCB. Oh yeah, that should conduct, well, at least one way. Sockets make it easy for you to steal the components later. Also handy if you, well, were unfortunate enough to get chips that never worked. Sockets have a sort of indent on this one side. This should match the one on the footprint. There are 3 of these small value capacitors. I like the yellow ones. They're 100 nanofarad, 5mm wide. Let's just get them installed. If you were worried about getting them in the right way, there was no right way, so you're good. The next thing we're going to install is the 40-pin female header. While regular Raspberry Pi hats have the Raspberry Pi, well, sitting below the PCBs, instead I'm inserting it onto the PCB. That's also the reason for the hole on the left side. It's simply where the larger ports on the full-size Raspberry Pi boards will descend into. These are electrolytic capacitors. They're polarized, which means that we have to get them in the right way, or they tend to blow up. Mostly you just need to ensure that the stripe is lined up with the filled in white area on the PCB. While we're here, let's just throw in a socket for the 5V power input. The PCM5102 module is the most common purple variety. It communicates with the Raspberry Pi over the I2S protocol. For anyone who's tried to use the onboard sound on a Raspberry Pi, you know we need something extra, and this is it. It has a set of solder jumpers on the bottom, so before continuing we need to ensure that it's set correctly, or set at all. Here's a picture of the jumpers when set correctly. The pads are quite small, but if you clean them with some IPA and then add some fresh solder to them, you can usually get it done. When in doubt, verify with a multimeter. The board itself I'm just attaching via these straight pin headers. Getting the alignment correct might be a bit tricky, but just hold your finger on it and then readjust. Just don't put your finger on the pin you're hitting, like I just did. Put the module in place. The audio jack should be towards the top, and that's just about it. All we need to do is ensure that it's not falling off, which is a job for, well, you guessed it, soldering iron. The area around the larger capacitor that we added earlier might prove to be a slight complication, but if we turn things around and do it a bit carefully, it won't be a problem. Barely melted at all, so relax. And now we are finally ready to work on the front panel. It's going to attach to the front panel using these right angle pin headers. Note that it's not going in on the component side of the board. Just break off the segments that you don't need. When first soldering it, I usually recommend starting with one of the pins. Then turn it over and reheat. This ensures that it stays perfectly flush against the board itself. Something that will be important later when we will attempt to put the two boards together. When we're done with that, we're going to install some of these 8mm hex standoffs to the inside mounting holes. The orientation of these is important. The reason is that when we go to mount it, we need a flat edge towards the inside. Here's a picture from later in the installation. Also note that I've shaved off a bit of the upper edges of the hex standoff. The reason is that we mostly need some extra room to work with. With all four corners done, we'll just put the components roughly into place. We won't be soldering anything just yet. First thing we need is some extra tall switches. These are the momentary tactile switches. They should be somewhere around 11.5 to 12 millimeters long to fit through everything. Next is one of those super cheap rotary encoder modules. It has a blue base to show that I'm cheap. After that's done, or at least put roughly into place, as we talked about, we fish out the LED that you hopefully didn't lose on the floor. Longer pin goes in the round pad. Still haven't soldered anything because we want everything to be just about right. And the way we do that is to put the faceplates in place. I'm just going to use a few hex standoffs for now. We just want it to stay put. Now that everything is roughly in position, we can ensure that we get a perfect alignment with the front panel. And finally, this is the point where we start soldering things again. You may have noticed that we haven't dealt with the display just yet. That's simply because it's easier to install later. On the back of the board, as part of the rotary encoder circuit, there are two solder jumpers. They control the direction of the scrolling on the encoder, but for the standard circuit I just recommend linking pins 1 and 2 on both of them. Pin 1 is shown by the little triangle next to the solder jumper. While we're on the subject of solder jumpers, there are some extra ones that deal with the display. The reason is that some of the displays have their pins slightly, well, randomized. Noting that the ground pin is listed first here, meaning that the P1 ground should be linked to pins 1 and 2, the other also to 1 and 2. If on the other hand it says VCC or VDD, then you need to link pins 2 and 3 on both of the jumpers. If your display didn't come with pin headers already attached to them, you need to solder them in place. At this point we can just insert the display pins into the PCB, but not solder it. Before doing that, we need to work with the alignment again. So I'm just adding the faceplate. To avoid having it move around while we're trying to align things, I'm going to use these long hex standoffs. They should go clear of the rotary encoder so that they can be put on a desk. I've not soldered anything yet, but I thought that before I would do so, I'd like to try inserting it onto the main module just to see that nothing is completely, well, out of alignment before we attempt to do that. With the module removed again, I'm just going to slightly move it around with my fingers to ensure that it stays flush, at least with the faceplate bottom, and then soldering a single pin. And just because I'm paranoid about these things, I'm going to turn it over and see where we're at. But for once it actually looks straight, so just check that it still fits the main module. I can't tell you how many times I've done this, but if I was ever going to get it right the first time, I'm fairly lucky it was on video, because usually I have to reheat and move it slightly around several times to get it right. Before continuing, let's just get those longer hex standoffs out of there and replace them with some proper screws instead. These are just 6mm, but they look a hell of a lot better. Remember those longer 20mm hex standoffs that you saw me use earlier? Well, now we're going to put them in their proper place, which is the four corners. On the bottom I'm just putting something that will be at least 12mm tall. Since they're plastic and I don't want to sharpen it on my desk, I'm just snipping them off. It'll be fine, I can buy new ones. Remember this photo that I showed you earlier? It was about alignment, and this time it's the taller ones on the outside that we need to deal with. So just rotate them so that the inside edge is flat. If you did a good job, then you can take the completed front panel module and insert it into the main PCB. As you've probably noticed, there are slots cut out into the main PCB. The front panel will slot into it. There may be some differences depending on where you had the PCBs produced. These were made by PCBWay, so they should fit. If they don't, then a file will help you. And by file I mean the kind you bake into a cake, not the kind you have on your computer. There are margins of error built into it. I find that the alignment is best corrected by just installing the top faceplate into place and screwing it firmly. The parts should adjust by themselves mostly. Turning it over, we can work on just soldering those connectors into place, which well, they're pins, just solder them. And we're back inside. BulkyMIDI-32 uses these 5-pin DIN connectors. They're used for MIDI input and output. As they're fairly large, you may need to reheat one of the pins and push it flush against the board. I picked up a Raspberry Pi 3A+ board that someone had tried to use in an Amiga earlier, but I guess they failed, and then sold it to me fairly cheap, probably thinking it didn't work. However, I don't want it to be flopping around in the female socket. And then, well, it's time for more hex standoffs again. I really do need to check my usage of those, because I always seem to run out. The one that we need should be around 11 millimeters, but I find that a 8 millimeters plus a nut on the bottom is, well, as close as we get without custom ordering something. There are only 2 chips on the board. They have an indent indicating pin 1. And this indent needs to be matched on the one with the socket. Taking care that none of the pins end up curling under the chip instead of going into the socket. The Raspberry Pi is just inserted like, well, so. If you do find that there's something in the way, there might be something on the front panel that might be conflicting with one of the ports on the Raspberry Pi. In this case it was just a part of the plastic screw, so I'm just cutting that off. With the Pi in place, you could add some more screws to ensure that it won't be going anywhere, but mostly you shouldn't have a problem. It just won't survive a drop test. Seems like I've been talking forever, so let's just roll some music and get the finishing touches out of the way. By the way, I was joking, that was the ad-lib version of Monkey Island. Here's the actual MT-32 version of the music. feel like there was a joke somewhere in there about having a nice knob. So that's the video. It was filmed during a hurricane and the voiceover recorded while having the flu. You're welcome. Next video will cover the process of setting it up, so join me then. Bye.